and we are just going to learn about. We learned basically a couple of things about the planets and stuff, I believe. Yeah, told you about how excretion was done, but then I just need to go in bit of more detail so that you guys also, understand it better. So there are a couple of processes that I want to, share with you. So please write the heading. Say it is the excretion model. So please write that sun is thought to be formed when gravitational forces of attraction pulled together clouds of hydrogen gas and dust. Okay, usually it is basically called when a nebula is formed. Nebulae is formed. Okay, like that. Now, so basically, our solar system was then formed 4.5 billion years ago. You guys need to remember that. So you guys need to remember the planets were formed from the remnants of the disk cloud of matter left over from the nebula that formed sun. Now, please write that the interstellar clouds of gas and dust included many elements that were created during the final stages of a star's life cycle. Usually, this process has a name. It's called supernova, but we are going to learn about this at the end of this chapter. Now, so when this happened, gravity collapsed, the matter from the nebula it on itself, causing it to spin around the sun. Now, the gravitational attraction between all the small particles caused them to join together and grow in an accretion process. So, a rotating disk, or we could say accretion disk, is formed when planets emerged. All right. So I'm going to show you a picture so you guys know what exactly this is, and then we're going to continue this. Wait a second, please. I wish I could have drawn this, but I don't have the time. But I will draw it later on once I have enough time. I'll just show you how it looks so you guys can actually just understand visually. Okay, so this is the stage 1 where you see it says that sun is thought to be formed with gravitational forces of attraction pulled together clouds of hydrogen and dust. This is how the sun looked, right? Then the planets were formed like this, and then it converted into, the other particles joined in together, sun grew hotter, and now we have the 5th model where planets are moving. Do you guys understand this? Okay.
Sir, what is
Sorry?
what is the number 1?
This is when, a cloud of gas was gas of like hydrogen gas and dust was formed. Okay. Let me just show you a better picture so you guys can actually view that. Wait, this I don't like at all. It doesn't have a lot of description. I found a better one. I'm gonna use that. I think you guys will be able to understand that even better. Okay, then we write it on the side. Okay, so basically it is like a nebula initially, as you can see, and then there are hotter regions, colder regions. Sun is turning to form, and then when the sun forms a few billion years ago, then rocky planets are closer to the icy bodies there, and slowly the other bodies combine around the sun, and then about 100 million later it becomes a solar system. Do you understand this? Zain, Hussein, Zainab, Yusra, Rabia, everybody understands this, Zarish?
Yes.
Okay.
Yes, sir.
Now, so I don't want you guys to doze off, okay? I can ask you a question anytime, so please be attentive all times. Now write here that as sun grew in size, it became hotter. So, inner planets forming near Sun had a very high temperature near them. Okay. So, therefore, the inner planets are made of materials with high melting temperatures, such as iron, right? Usually metals. Okay. Only 1% of original nebula is composed of heavy elements. So, inner rocky planets could not grow much and stayed as a small size, solid and rocky. Right? Now, due to this temperature, and the reason why it's not, they can't grow, because due to this temperature, molecules as molecules of hydrogen, helium, water, and methane could not exist in solid state. So that's why, the rocks just were left. All right. Now, the cooler regions, which are considerably far away, were further away from sun, and temperature was low enough for the light molecules to exist in a solid state. Now, this is the reason why the other are gaseous ones, at the end, because outer planets therefore could grow to a large size up and includes even the lightest element, such as element hydrogen. So that is why these planets are gaseous and cold. Is that clear, everybody? Any question? Najaf? Zainab? Afan?
No question.
Pretty cool. If you want, you can actually take a screenshot of the diagram. Otherwise, I'm also gonna send this PDF to you. Don't worry about that. Okay. Now, we're going to do a question. So the question is, the distance of sun from Earth is basically 1.5 times 10 raised to power 8 kilometers. Okay, calculate the time in minutes for the light to reach us from the sun. Can you guys do it? Please. Think about it. Then how would you do this? And then try to, you know. 8.25 times 10 is for 19 minutes. Don't you think so? That's too long for light to reach us. That's not correct, Afan. Any other answer, please? Give me an answer. That's not fair.
Like 8.3 seconds.
8.3 seconds. Okay, let's try this. So, first of all, there are a lot of data, like the distance is given in kilometers, right? So it's So we need to change this into meters. So it should be 1.5 times 10 raised to 11 meters. And then the speed of light, if you remember, is 3.0 times 10 raised to 8 meters per second. You should remember this. Now, speed is essentially just distance over time. So distance is 1.5 times 10 raised to 11 divided by time is, sorry, we need to find time, my bad. So then time will be 1.5 times 10 raised to 11 and speed is 3.0 times 10 raised to 8. If you try to find this, so it is about 500 seconds. Now, how do we convert seconds into minutes? So we got divided by 60. So that's going to be 8.3 minutes. Is that clear, everybody? So the light you see shining on us basically reaches about 8 minutes late from where it is produced. Understood, everyone? Any questions? Okay. Now, another question that I want to discuss with you. A table of data of planets. So these type of questions will come in your exam. In our solar system is provided. Let me just put it. Second, please. Now, so it will just show up. Okay, now it says question 1. Why does Earth, in fact, let's not talk about Earth. Why does Mercury has a greater speed than Neptune? Okay, so we want to write this, and then in the second question it says that the gravitational field strength of okay, so it says the gravitational field strength of Earth is about 4 times larger than Uranus, right? Suggest the reason why, although Uranus is larger in size than Earth. All right, look at this and please try to answer these questions. That would be the last thing we're going to do today. One question I'll add it from my own self. Surface temperature of Venus is larger than Mars, as you can see, right? Although the temperatures decrease as we go towards planets farther away. Suggest why. Okay, 3 questions. Look at the table and answer, please. One by one, I'm going to ask you this. All right, anybody got the answer for the first one? Rabia, Yusra, Zainab?
Sir,
Yes,
it's closer to the sun,
it's closer to the sun. So,
but like the distance is smaller.
so
But compared is smaller,
there has to be some other
like the
reason.
distance you cover.
There has to be some other reason. Why is the speed more?
It also has less density.
No, 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 no,
It has more than
no, 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 no. That's not correct. That is not correct. Although you see the duration is increasing as the distance is increasing, so then the point is we're not talking about the duration. You're not understanding it. They're asking you about the speed. So what you're going to do is you're going to say, okay, for Mercury it is 57.9 is the distance covered. It's 2 pi r over time period, right? Orbital speed 2 times pi times 57.9, and then we're dividing it by 88 days, so it's basically 4.9 for that. And for Neptune it is like, you know, the distance it needs to cover is a lot, and the time it takes is like in years, which is 165, and divided by, we also need to multiply by 365 because we need to do in days. So it's very small. You see how small it is. Why? Because the reason is that as Neptune is farther away, it also has less gravitational pull on pull of the sun. Hence, its speed is less. Do you understand? It has nothing to do with the duration. It is to do with the speed and the force. Do you get my point? So larger the gravitational field strength, larger the gravitational force on the planet, the faster it is going to move. Is that clear?
Yes.
Okay, now it says the next one is the gravitational field strength of Earth is about 4 times larger than Uranus, which is true. No, wait. The gravitational field strength of Earth is about the same as Uranus. So that's the reason why, although Uranus is 4 times larger in size. Do you understand? Now answer this, please. Sorry, I wrote it wrong. So Uranus is 4 times larger, but it is almost, in fact, it's a bit smaller gravitational field strength. Tell me the reason why.
Sir, does it have something to do with the speed?
No, it is not to do with.
And does it have to do anything related to the distance from sun?
No, it has to. No, that's not true. Not correct. Zarish, any idea? Caroline, Chavez. The why boys don't speak in this class? Why? Okay. The reason is that now you guys need to understand that the gravitational field strength basically is G, right? It is weight per unit mass. You know this. Does not depend on size but the mass. So although the size of Uranus is larger, but mass is smaller, as Uranus has a smaller density. Smaller density means it has less mass but more volume. Do you understand? It's basically gas. Do you guys understand?
Because it's a gaseous one.
Yeah, so it's big in size, but the mass is small. So density shows it. Like Uranus has 1271 and Earth has 5514. Do you see the difference?
भाई वैस मैं ना डॉक्टर सुबह के पास जा रही हूँ मेरा बीपी बहुत लो है
ठीक है.
आपके पापा के घर में नहीं हुआ है तो उनको बता देना फिर वो पूछते हैं
ठीक है. Is that clear? Now,
Yes.
then the last question I wrote was surface temperature of Venus is larger than Mars, although the temperature decreases as we go towards planets further away. Like you see, Mercury has 350 and the surface temperature of Venus is 460. But as we go down, the temperatures are constantly decreasing. Why is there an increase here? Anybody has an idea? Wildest idea that you might have?
Are there any specific elements found on Venus which just happen to have a higher temperature?
No, that's not true. It's not closer. Now, you could basically say, basically, there's a reason.
आपके पास 100 रुपया तो दे दो, मैं भजिया भी बना के दे दूँ।
So basically, what you need to remember is, and that's something just mark my words. General knowledge. Venus has a dense atmosphere of carbon dioxide. And do you know what carbon dioxide does? Why is it so famous in Earth also? It it does what?
It's dense.
No. It causes heat trapping. That is called the greenhouse effect. Studied in grade 8, right? Remember? That's what you guys need to remember. Okay? So that's why it just has a lot of trapping of heat. That's why the surface temperature is so high. Any questions now?
No, sir.
Good. So then we'll talk about more. We'll basically talk about this tomorrow then, hopefully. So if you have any questions, please let me know.